In this we discuss LeetCode problem 1110. Problem name is delete node and return forest. Right. So what is the problem? Problem statement is that given the root of a binary tree, each node in the tree has a distinct value. Okay. After deleting all nodes with a value in to delete, we are left with a forest, a disjoint union of trees. Return the roots of the trees in the remaining forest. You may return the result in any order. Okay. So there will be given a binary tree, right? So binary tree means one parent node will have maximum two child. This is binary tree, and here actually they mention that the value of all nodes are distinct, right? And they will given an array vector, or actually they mention the to delete. Okay, and after deleting these nodes, we have to return the forest. Forest means the root of all the different tree. So suppose for this tree, 1, 2, 4, 5, 3, 6, 7. Okay, and what is the value they are trying to delete? 3 and 5. Right. So if I delete 3, then what is the tree will look like? 1, 2, then 4, then 5, then 6, then 7. Right. So this is actually 1, 2, 4, 5, 6, 7. Right. So if I delete, I have deleted this node 3. So after that, what is actually this actually graph will look, tree will look like? Now we want to delete, suppose this 5. Okay. So what will be the structure? Like this will be 1, this is 3, 2, this is actually 4, and 5 has been deleted. So this will be the 6 and 7. So this will be 1, 2, then 4, and 6 and 7. So if I have to return this tree, then which value actually return? I have to return the node of this, node of this, and node of this, right. So the result I have to return the 1, 6 and 7, right. So here actually we have actually some observation here. Like here, what is the observation? Like we have any tree. Suppose this is our tree actually. Okay. Suppose this is 1, 2, 3, 4, 5. Now suppose I want to delete 1. What actually situation actually I want to say actually. Suppose I want to delete 1. Then what will actually tree structure? This will be 2. This will be 3, 4 and 5. 3, 4 and 5. Right. Whenever you are deleting any root, root not 1, then this actually have a graph look like. Suppose I want to delete here for this graph, I have to delete 3. Okay. Then what will be actually tree structure? 1, 2, 3 have been deleted, 4, then this is 5. Right? So in this case, you can actually see that this will actually right pointer will be null. Right? But this will be exist. Now suppose I want to delete here actually, this will be the like here actually we are deleting root. Now in this case we're deleting any mid node, right? Now I want to delete one situation more. I want to delete 3 and 5 both. Okay, 3 and 5 both. Then how does actually graph will look like? 1, 2, 3 have been deleted, 4 will be still there, and 5 have been deleted. This will be actually tree structure, and the answer will be 1 and 4, right? So for root case, I have to check only for the left pointer and right pointer. Here actually we are what we are storing in the answer 4 and 5. Right. For this, whenever deleting any mid node, then what will actually answer 1, the root pointer, 4 and 5. Because the 4 and 5 is the left and right side of the 3 that have been we have been deleted. Now for this situation, whenever deleting any two consecutive parent and child both, that time what actually I have to think, right? Root will be always root will be here if it is root have been not deleted. Then we are also deleting the child also, and the left child here actually is still in our answer, right? So in this problem, what actually I have to solve, like whenever we have to check that whenever we are in the current node, any node, random node, okay, I have to check that this will be deleted or not, this will be deleted or not. So how I can actually check? I will check that this value, the value of this current node is present on the to delete vector or not, right? If it is present, then what actually I have to store? What I have to store in the answer? Like if it has a left child, then it will be in our answer. Left child answer means in the vector of forest, right? And if it is right child also, that will be also in our answer. Suppose we are deleting 1, 2 and 3. Here actually deleting 1. Suppose current node are 1. So this will be deleted. So in answer I will store 2 and 3 because this is actually new, this new root of the new tree of the left child, and this is the new root of the right child, right subtree. Got it? But that's why I have to store 2 and 3 both, right? And for this we got it, right? But whenever we are going to the parent means suppose we are deleting 1, 3, 4. Here actually I have 2. Okay. Now we want to delete 3 and 4 both. Both value is present in the or to delete vector. Okay. So, first of all, I want to delete 4. Okay. So I delete 4. So the graph will look like 3 and 4 have been deleted. Got it? So for a minute, how actually I will check. Okay, I will check what is the left and right side before deleting the node 4. I will check is there any left side? No. So that's why there will be no new left subtree or right left subtree. Then I will go to the right side. Is there any right side on the node 4? No. So there will be no new right root of the right subtree. No. That's why not our answer vector is still empty. Got it? So I'll delete this. Okay, I will delete this. And what will be actually the right value of this 3 will store actually, ultimately. This will actually store null because 4 have been deleted already. Okay, now we are coming to node 3. Okay, then I will check is there any left child? No, because 3 will be deleted. So I have to store the next root subtree, left subtree and the right subtree. Then I will check is there any left child? No. So I don't have to store in the answer anything. Then I go to the right. Is there anything on the right subtree? No. It was there, 4 was there, but it have been already deleted. That's why I will store in the null. Okay. Then that's why there is no left and right subtree. Then I will delete this. In the parent, I will store null. Okay. Return null. So it will store in the right subtree as null. There is no right child ultimately after deleting this. So graph will be like 1 and 2. Got it? Now I will check. One will deleted. No, one will not present in the to delete vector. So I will end our visitation. Now what I will check that this 1 is actually present in the to delete vector or not, right? If it is not present, then what I do? I have to, like if it is not present here, actually 1 is not present in to delete vector. To delete vector only present 3 and 4. Okay, so but our answer vector is still empty. But if I return from this point that okay, I have visited all the node and I have deleted all the nodes that actually I have to delete. Now I am returning the answer vector, but the answer vector is still empty. In this situation, or after visiting the graph, it will return that there is no element in the tree. Okay, so that time I have to check that these root have been deleted at the end. After visitation on the tree, I will check at the end that 1 have been deleted or not. If it have been deleted, then no matter 2 and 3 will be in the present in the vector answer vector, because before deleting I will check that this actually present or not, this actually going to delete or not, right? So that's why at the end I will check that 1 is present, 1 is going to delete or not. Okay, so let's go to this is DFS approach. You got that how actually DFS is working here. So I actually have to return this this is a return type vector of tree node pointer, and I have taken an answer vector. Okay, now I have taken another set. I will explain it later. Now I am calling a DFS. Okay, horizontal passing the root node pointer, and this another set and the answer vector. Okay, so I am calling this DFS vector, DFS function. So I will get a node, any node, random node, and get a set and the answer. So if it is a node is currently null, so I have to return null pointer. Okay, because there is no node. And here actually we are calling in the left and right subtree. That's why I am calling the DFS of the left subtree and the DFS of the right subtree. Got it? And I am storing this in the left and right. Why I am doing this, I will explain it later. So now I have taken this set. If I don't use this set, why I am using this set? Because I have to check this any current node. Suppose we are in this node. So I have to check this node is going to delete or not. So how I have to check? I have to check this node value of this current node is present on to delete vector or not. That time what I have to do? For each value, I have to iterate the whole vector to delete vector and check that this value is present in the two value or not. Right, that time what will the time velocity of check? Big of n is the size of the two letters n. But if I use the set, then it will time velocity big of 1 or big of log n. If I use ordered set, and if for another it will take big of 1. Got it, right? So to optimize this, we have actually used the set. Got it? Why I have actually used set? Otherwise, you can actually use the vector also, and you can actually traverse the whole vector to delete vector and check this value is present or not. But now if it is present, suppose value is matched, then what will I have to do? This node will be deleted. This node will be deleted. So before deleting, what I have to I have to store this left and this right. Then I will check, is there any left subtree present? If it is present, then I will store the left pointer into our answer. Got it? And similarly for the right child, if there is any right child, then I will check. If it is present, then I will store the right child pointer into our answer, because this will create a new for a new tree, and the root of the new tree will be this left child and the right child. Got it? Else, if there is no child, suppose this is going to delete. So there is no left and right child. So they will not create any new forest, new tree. That time I will not store anything. Okay, and return null pointer. Got it? Else current. Why? Return null pointer means this node have been deleted. Right? Because in the parent it will store as a right as a null. Otherwise it will store in the current node that okay, there is any right child present actually, but this is actually deleted. If it is deleted, that time actually it is actually null pointer, because there will no child of that point position. Got it? And else I will return the current as node as the current node as the answer. Okay, got it? And here actually why I am doing the current left first and the current right first, because there is any situation present in this way, like we want to delete 1, 2 and 3. 1, 2, 3 is our tree structure, and I want to delete 2 and 3 both. Okay, so if suppose if I do this two operation in the after, okay, after this operation, after this deletion, then what will I do? I will delete 2. Okay, then I'll check, okay, is there any left child? Okay, no left child. Okay, no problem. I will go to the check for the right child. Okay, is there a right child? 2. Yes, there is a right child. So I will store in the answer 3. Okay, got it. But this is actually true. No. Why? Because 3 will be also deleted. So I have to know the ultimate. Is there any left child or right child present or not? Ultimately. So I have to check from the bottom to top. Like bottom means I have already done all the operation at my child level. So I know that ultimately there is no any left child or right child present or not. So that's why I will take decision. Okay, if I any left child pointer, then I sure that there will be left child. Okay, but if I before doing the operation at the child level, if I take the decision at the parent level that okay, is there any left child or right child, then it will be actually wrong. Right? That's why first of all do the operation at the child level, then take the decision ultimately that is there any left child or right child present or not. Got it? And in this actually we will suppose is there any tree like 1, 2, 3 and 4. So suppose I want to delete 2 and 4. So first of all I will delete 4, and here actually there is no left and right, so go to the return here from null. Okay, so here actually 3 1, 2 and 3 graph will look tree will look like this. 4 have been deleted. Now what will happen? I will check, okay, 3 is going to delete. No, 3 is not going to delete. Okay, I'll return is 3. So 2 have right child as 3. Okay, now I want to check for the node 2. 2 is present in the two-lead vector. Yes, this is present. So I will delete this. So is there any left child? No, there is no left child. But there is right child? Yes. So I'll store this into our answer vector. Got it? And I will delete this 2, and ultimately one have no left and right child because there was a right child 2, but it been deleted. Right? So ultimately the tree will look like 1. They do not have anything any child. So I will check, okay, one will be deleted. No, one value is not present in the to delete vector. So I will return from this. Okay, so before delete, but our answer vector have 3 only, but I have to return 1 also. That's why at the end I will check is the root value, what is the root value have been present in the to delete vector. If it is not present, that means what? It will not be deleted. So I have to return this explicitly. So that's why I will push this into our answer vector. Got it? And I return the answer. So what is time velocity of this? Time velocity of big of n. Why? We are visiting each for the DFS. We are visiting each node only once, right? That's why time velocity of big of 1. And you can also consider the searching operation like st.find, stack.find. That time actually n login or n. If it is another set, then it's actually n. Got it? Constant time big of 1. And what is the space complexity of that? Space complexity, we are using a another set. So another set time velocity will be big of m. If is the size of the two vector is m, suppose, right? Got it, right? For this is the DFS approach. For this problem, I can actually solve this with BFS also. How? Like we know 1, 2, 3, 4. So I actually mentioned that there is 2 situations. Current node will not be deleted. This is the simple case. So I don't have to do anything for this situation, but current node only will be deleted. So suppose this node will be deleted. 3 will be deleted. Okay. Now what will the tree will look like actually after deleting of 3? 1, 2 and 1 out, it will be null, and 3 will be deleted, so 4 will be alone, right? So this one have to know that this 3 is going to be deleted, right? For BFS actually, in DFS we can actually call the left child and right child before, and then actually we can do the operation for the current node, like main parent. But here actually BFS means what? We will traverse the each node level wise. First of all, we will traverse 1, then we will traverse 2 and 3, then we will traverse 4, right? So there is no parent concept. Like I can't go to 3 to 1. That's why before going to like next level, like 2 and 3, I have to set this 1 right child as null because 3 is going to delete. So I will check that my current any child is going to delete or not. If it is going to delete, then set that child as null because this is actually going to delete. So I will just cut the connection. Means this connection will be deleted. Cut. Right. Now suppose I have done actually this operation. Now I have coming to this 3. Right. Now I will come to this 3 and I will check. Okay, 4 is going to delete. No, 4 is not present to delete vector. So but 3 is going to delete. right? So I have actually any connection. Yes, there actually effectively there is any right child present 4. So before deleting this, I will check, is there any left child? No. Is there a right child? Yes, 4. So and the answer I will push 4 because there is a right child. Okay, and now I will come to this 4 because I have already visited 2 and 3 level wise. Now I come to this level 3 as 4, not 4. So I'll check, is this value is present in the to delete vector? No. So this will be present, and there is no child, so I don't have to do anything. So our answer contain only 4, but one is still I have to return. So similar way for DFS skills also, that I have checked at the end that root has been deleted or not. So similar way I'll check if this is going to delete or not. If it is not going to delete, I will push this into our answer. Okay. This is for simple one case. Suppose now want to delete 1, 2, 3, 4. Now want to delete 3 and 4 both. Okay. So first of all, BFS traversal. So I'll come to 1. I'll check 2 is going to delete. No. So this connection will be still there. Now I will go to the right child. Right child is 3 is going to delete. Yes, 3 is going to delete. So I will just cut this connection, right? And I will set this as null. Right? Got it? Now I will come to 2. 2 is going to there is any left child, right child? No. 2 is going to delete? No. So there I don't have to do anything. Now I'll come to 3. So I will check 3 is going to is there any left child, right child? Yes. Left child, right child is there. So left child is no left child, but right child I have right for 3. So this is going to delete. Yes, 4 is present in the to delete vector. So I will set this. I will first cut the connection between 3 and 4. So I will set as null. Got it? Now I'll check 3 is going to delete or not. First of all, I will check for the child wise, because ultimately I have to do the ultimately is there any child or not? I have. That's why first of all check child is going to delete or not. Right. Then I'll check I am going to delete or not. First of all, I'll check that the child is going to delete or not. If child is, I will know the effective what is the value. Then if it is not going to delete, then I will check I am going to delete or not. If I am going to delete, then if I have any child, that will be actually for create a new tree. So that I have to store. So that for this I will check, okay, 3 is going to delete. Yes, 3 is going to delete, and this is present in the to delete vector. Okay. So I have any left child, right child? No. So I do not create any new forest. Got it? Now I go to level as I have completed all this level. Now I'm going to node 4. So I'll check 4, is there any left child, right child? No. I don't have to do anything. Now I am going to that 4 is going to delete or not? Yes, this is present. So this will not only going to delete. So I'll check, is there any left child and right child? No, both are null. So I'm not creating any new forest. Got it? So that's why answer is still empty. Got it? So I have done all the BFS visitation. Now I'll check for the same case for the root. 1 is going to delete or not? If root is going to delete, so I'll check. Okay, 1 is not present, so this will be present. So I will just push this into our answer, and this will return. So after start from visitation from 1, I will first visit 1, then 2. I can print. But so let's go to the code actually. So similar case, I have to return a vector of answer, a vector of tree node pointer, and answer I have taken, and I have taken a set. I've already explained why I have taken a set. And for BFS, we need a queue, right? So here queue type is data type is tree node pointer. Initially, I am going to insert root into the queue. So till our queue is not empty, I will just do the operation. What is the operation? First of all, pop the current node. Pop means okay. Now I will check, is there a left child? Okay. Then I'll check left child means I have to visit this because this is BFS. So I'll just push this into our queue. Okay. Now I'll check, is the left child going to delete? Yes, this is. If it is going to delete, then how will check? I will just check that value is present in the set or not. Not equal to int means what? Current left will be null actually. ultimately, suppose we are in here, current node, and this is going to delete. So ultimately, if it is going to delete, so ultimately it will be null. Left pointer will be null. That's why I'm setting this as a null. Okay. Similar for the right child also. I'll check. Okay, is there any right child node? Yes. Then I will just push this into the node into the queue. Okay. Then I will check. Is my right child going to delete or not? How will check? I'll check the value of the right child. If it is present in the set, then I will set this as a null. Got it? Ultimately, I will just disconnecting with parent to the child. Now this is for child level. Now for this is actually current level. I've done all the I know already for here from here that ultimately I have any left child or right child or not. Got it? Now for the current level, I'll check I am going to delete or not. If I am not going to if I am going to delete, then I may create new forest. Let's have check my current value is present in the set or not. If it is present, then I will add the current left pointer. If it is present, left child is present, then only answer will in the answer I will just push the current left child. Similar for the right child also. If is there any right child, that will create a new forest. That time I will push this the right child into our answer. Got it? In this actually we will do the operation, and at the end similar way for the root situation, I will check this root is going to delete or not. If it is not going to delete, I will push this into our answer and return answer. So what is the time concept of this? I am traversing each node only once. If there is n nodes, so I am traversing each node only, so big of n. Space complexity, we are taking a queue, so space will be big of n, not n, the word level, maximum level, L. Got it? And anything, yeah, set we are taking, so set will be big of m, if the size of the 2-digit vector is m. Got it? Anything when using anything extra space? No. Got it, right? And also understood the logic also, right? Thank you.